Today we are going to classify numbers. In 6th grade, we only deal with rational numbers. Next year in 7th grade, you'll deal with irrational numbers, but this year we're only dealing with rational numbers. Well, what do rational numbers include? Rational numbers include fractions, decimals, percents, natural numbers, whole numbers, and integers. Basically, it's all the numbers that we will be using in 6th grade. So any number that we use in 6th grade is going to be a rational number. Now, let's talk about the different categories, because within rational numbers, there are natural numbers, whole numbers, and integers. So look at this circle. This circle, the big circle is kind of like a big box, right? Within the big box, there's a large box. Within the large box, there's a medium box. Within the medium box, there's a small box. So I'm going to use this little toy dog that looks kind of like my dog Einstein as an example. If I put Einstein in the smallest box and I wrap him all up, I wrap him up in the small box, then I put the small box in the medium box, then I put the medium box in the large box, and then I put the large box in the extra large box. What box is Einstein in? Well, Einstein is actually in all 4 boxes. So he's actually in all 4 circles here, okay? Because he's in the small circle, and the small circle is inside the medium, and the medium is inside the large, and the large is inside the extra large, he's actually inside all 4 circles. So if you have a number that is a rational, an integer, a whole number, and a natural number, you would put them in there. You would put the number in there because that means it's in all of them. If Einstein was only in this box, or this circle, then he's in 3 of the circles. He's in the medium, the large, and the extra large circle. If I put Einstein in this circle, then he's in the large and the extra large. If he is only in this circle, then he only belongs to the extra large circle and none of these. So when we're putting numbers into our Venn diagram, we have to think, do they belong in all 4 circles? Only 1 circle? Maybe just 2 of the circles? Maybe 3 of the circles? So we have to think where each number belongs. Well, let's talk about the different categories of numbers. There are your natural numbers, which we can also call your counting numbers. So when you play hide and seek, you start with 1, 2, 3. You naturally start with 1 when you're counting. So your natural numbers, which are your counting numbers, are 1, 2, 3, 4, 5, 6, and so forth. Okay? The natural number circle is inside the whole number circle because your whole numbers include all the natural numbers, the 1, 2, 3, 4, 5, 6, on to infinity, plus the 0. So the only difference between whole numbers and natural numbers is whole numbers include a 0. So your whole numbers are all your positive whole numbers, including 0. So 0, then 1, 2, 3, 4, 5, 6, and so forth. So your whole numbers include everything that are in your natural numbers, and then plus the 0. Okay? Now, integers, as you can see, integers include all the natural numbers, all the whole numbers, and then plus what? Plus all their opposites, all the negative whole numbers. So integers are all your whole numbers and their opposite, which are the negative whole numbers. So these are your integers. Now, the natural numbers and the whole numbers are inside the integer circle because the integers includes whole numbers and includes your natural numbers. So both of these are inside the integer circle. Okay? And then, of course, all 3 of these are inside the rational number circle because rational numbers includes natural numbers, they include your whole numbers, they include your integers, plus your fractions, your decimals, and percents, which these do not include fractions, decimals, and percents, right? Because fractions, decimals, and percents are only parts of whole, not a whole number. So your rational numbers includes all 3 of these, plus fractions, decimals, and percents, okay? So let me give you some numbers, and you decide where we should put them. So let's say I have negative half, 3.5, 6, negative 8, 0, 10 over 2, okay, and negative 7.0. Oh, let's do one more. Let's do, oops, let's also do 60% here. All right. So let's put each of these numbers in the right category. So let's look at negative a half. Is it one of our counting numbers? Is it 1, 2, 3, 4, 5? No, it is not. So we're not going to put it in this circle. Is it part of our whole numbers? Is a half, and a negative half at that, is it a whole? No, it's only a part, so it's not part of that. Is it an integer? Well, integers are your wholes and the opposite, which are your negative wholes. And this is not a whole, so it can't be an integer. So that means that it is only part of the rational numbers. So since it can't be in any of these circles, it can only be in the large circle. So we're going to put negative a half right there. Okay? Let's look at 3.5. This 5 is a little messed up. Okay, let's look at 3.5. 3 and 5/10. Is it one of our natural numbers? Remember, our natural numbers are 1, 2, 3, 4. So it's not one of our natural counting numbers. Is it a whole number? Well, because of the 0.5, which is half, it is not a whole number. Is it an integer? Integers are only wholes and their opposites. So that is not a whole. So it's not an integer. Then that means it's only rational numbers. Remember, all numbers that we use in 6th grade are rational numbers. So basically, all these numbers are rational, right? Since it's not a natural whole number or integer, it can only fall in this circle with the rational numbers. Because remember, rational numbers are your natural, your whole, your integers, plus your fractions, your decimals, and percents. So there's your decimal. So 3.5 would be just in the large circle. Let's look at 6. Is 6 one of your counting numbers? Yes, because if you were to count 1, 2, 3, 4, 5, you would land on 6 as well. So it's part of the counting numbers. It's also a whole number, and it's also an integer, and it's also a rational number because all numbers are rational. Since it's all 4 of these categories, we're not going to put 6 here, 6 here, 6 here, and 6 here. Okay, you can't do that because if you put 6 out here, you're saying it's not part of these circles. So since 6 is all the categories, which circle should we put it in so that it's in all the circles? We put it in this circle because this circle is inside this one and the large one. So 6 is really inside all 4 circles. So 6 would go there. Negative 8, is it a counting number? Nope, because counting numbers are 1, 2, 3, 4. There's no negatives in counting numbers. Is it a whole number? No, because whole numbers are all positive whole numbers. Is it an integer? Yes, it is, because negative 8 would be the opposite of positive 8. So integers include your wholes and their opposites, right? So it is a negative whole number. So it can go here. And is it a rational number? Yes. So that means negative 8 is both rational and integer. So which circle would it go in? This one. Because if we put it here, it's in both this circle and the large circle. But it's not inside these two smaller circles. So a negative 8 is an integer and a rational number. What about 0? Is 0 part of our counting numbers? No, because when we start counting, we start with 1. Is it part of our wholes? Yes. Is it integers? Yes. Is it rational? Yes, all the numbers are rational. So it's actually 3 of them. It's a rational number, it's an integer, and a whole number. So where do we put the 0 so it's in all 3 of these? We would put the 0 in this circle because this circle is inside this one and this one. So the 0 would be in all 3 of these. Now, this one's a tricky one. 10 over 2. You might say, oh, it's a fraction, so it's not natural, it's not whole, it's not integer. Well, look at 10 over 2. It's an improper fraction. 10 over 2 actually equals 5 wholes. Because it equals 5 wholes, it's part of the counting number because there's 5 wholes there. It's part of the wholes. It's part of the integers. And it's a rational number. So since it's all 4 of these, we have to put 10 over 2 in the smallest circle because the smallest circle is inside all 4 of these circles. 10 over 2 equals 5 wholes, which is why it's all 4 of these. Okay? Negative 7.0, well, negative 7.0 is the same thing as negative 7. Negative 7 is not in our counting numbers. It's not part of our whole numbers, but it is part of our integers, and of course, it's also a rational number. Since it's integers and rational numbers, it would go there because that means it's in both of these circles. Okay? And our last one is 60%. Now you might say, oh, 60, that's like a whole number. It's 60%. If I give you 60% of my candy bar, did you get a whole candy bar? No. So 60% is only part of a whole. If it were 100%, then it would be a whole. So it'd be counting, it'd be in our wholes, and it'd be in our integers and our rationals. But 60% is only a part. So it's not a whole. So it's not part of the natural numbers, it's not part of the whole numbers, it's not an integer because integers are your positive and your negative whole numbers. So 60% would just be in the rational number circle. And that's how we categorize our numbers. It just depends on if it's in all 4 categories, in 3, or in 2, or just in 1.